Hello children, welcome to AIMS India's online classes. In today's class, from mathematics subject, factorization topic we are going to continue. So in our previous videos, we have completed all these topics children. So up to remainder theorem, we have completed the concepts. Now in today's class, let's start with quadratic expression. Quadratic. Actually, the meaning of quadra is 2. Quadra means 2. So, quadratic expression, which means an expression of the form ax square plus bx plus c, means the expression should be in the form of ax square plus bx plus c, means x square term, x term and constant term. X term means x power 1, we can take it as x power 1. Constant term means it's the x power 0 term. We have x square term, x to the power of 1 term, x to the power of 0 term, which is nothing but a constant. Means out of all the 3 terms, if the highest power is 2, or the highest power, one minute children, 1 minute. One minute children, there is some issue with the stylus. Okay. Suppose ax square plus bx plus c. Here the highest power is 2. So actually the highest power is called degree of the expression. Degree of the expression, which is 2. So it is called as a second degree expression, or second means quadra. So it is called as quadratic expression. So the expression which is in the form of ax square plus bx plus c. So where the highest power is 2 or degree of the expression is 2, that is called as quadratic expression. So in this expression, here x is the variable, remaining a, b, c, whatever things we have here, these are all real numbers. Real numbers means they may be a natural number or whole number or integer or rational numbers or irrational numbers. These are all considered as real numbers. So only they should not be in the form of root of -1, which are considered as imaginary numbers. So the value of ABC should be any one of these, which are all subsets of real numbers, but not imaginary. So then it is called as a quadratic expression. In the given expression, suppose if this coefficient is imaginary number, then it is not a quadratic expression. So all ABC should be real. So now if you take this example, we have 4x square plus 3x plus 6. So we have x square term, x term, constant term. Highest power is 2. So it's an example of quadratic expression. Next, another example. X square term, x term, x power 0 term, constant term. Quadratic expression. Here, next example. X square minus 4. Here, x square term is there, but there is no x term. So we can take it as 0x. And after that, constant is there. There may be one term missing. But if the leading term, if the main term, x square term is there, though there is no x term, only there is constant term, still it is to be considered as quadratic expression. But if there is no x square term, Suppose if we have only x plus 4, here there is no x square term. X square term is missing. X term. So highest power of expression is 1, which is not quadratic. So x square term compulsorily it should be there. So then only it is called as a quadratic expression. Next children, monic quadratic expression. Monic quadratic expression. So here in this example, we have taken ax square plus bx plus c. But a quadratic expression which is in the form of x square plus bx plus q, or just x square plus bx plus c, where this a is missing, or where the value of a is 1. Where the value of a is 1 means the coefficient of x square term, if it is always 1, and the coefficient of x term and a constant term may or may not be equal to 1, but x square term compulsorily it should be 1. So then it is called as monic quadratic expression. Monic quadratic expression means leading. This is the leading term actually. For quadratic expression, this is like the main term. So it is called leading term. Leading term, and the coefficient before the leading term, it is called leading coefficient. Leading coefficient, which is to be always 1. So then that type of quadratic expression is called as monic quadratic expression. Monic quadratic expression. Here children. Next illustration children, one example. The question is, find the monic quadratic expression which when divided by x minus 1 and x plus 2 leaves remainders minus 2 and minus 5 respectively. Let us assume f of x is the monic quadratic expression which when divided by x minus 1 leaves a remainder minus 2, which when divided by x plus 2 leaves a remainder minus 5. So as per remainder theorem, what we have learned, if suppose if f of x is x square plus ax plus b, because it is a monic quadratic expression, x square coefficient to be 1, remaining terms may have other coefficients. So that's why we have taken its form as x square plus ax plus b. Let us assume it as f of x. If it is divided by x minus 1, remainder is minus 2. If this f of x is divided by x minus 1, actually according to remainder theorem, remainder is f of 1, which is equal to minus 2. So they have given f of 1 equal to minus 2. How to find out f of 1? In the place of x, we have to keep 1. So this will become 1 square plus a into 1 plus b. Plus b. So 1 square is 1. A into 1 is a plus b. So this 1 will go towards right hand side. It will become here a into 1 a. Again b we have here. Here we have minus 2 on right hand side. If 1 square goes towards the right hand side, it will become minus 1. Minus 2 minus 1 equal to minus 3. So a plus b equal to minus 3. This is the first relation we have got as per the given hint. Now, if it is divided by x plus 2, then the remainder is minus 5. Suppose if the expression is f of x, if it is divided by x plus 2, remainder is minus 5. But the remainder is, according to remainder theorem, remainder is f of minus 2, which is equal to minus 5. So f of minus 2 equal to minus 5. In the place of x, minus 2 we have to keep minus 2 whole square. Ax means a into minus 2 plus b as it is. Minus 2 whole square will become 4. A into minus 2, minus 2a plus b. This 4 will go towards right hand side. Already we have minus 5 there. Then we will get minus 5 minus 4, which is equal to minus 9. So minus 2a plus b equal to minus 9. So this is the second relation we have got. So we got two equations in terms of a and b, defined in terms of a and b. So if we solve these 1 and 2, then we will get AB values. Then we will get monic quadratic expression value. So first one is on adding 1 and 2, a plus b minus 3, 2a minus b equal to 9. On adding, bb gets cancelled, a plus 2a equal to 3a, minus 3 plus 9 equal to 6, 3a equal to 6, or a equal to 2. We have got a equal to 2 in a plus b. In a plus b equal to minus 3, if we substitute a equal to 2, and this 2 goes towards the right hand side, it will become minus 3 minus 2, which is equal to minus 5. So b value we will get minus 5. So a value we have got 2, b value we have got minus 5. So the expression is x square plus 2x minus 5. X square plus 2x minus 5. This is the monic quadratic expression. Next one, algebraic identity. Algebraic identity means algebraic identity means it is an algebraic equation that is true for all values of the variables occurring in it. Occurring in it means it is called as identity. It is called as identity. Why means if in that identity or if in any equation, suppose we have a variable, if we keep any value in the variable, if it is true for any value of the variable, equation means you will be having LHS and RHS. You will be having LHS and RHS. If you keep x any value in the place of x, both LHS equal to RHS, it is always becomes true, then it is considered as an identity, and you can use it as a formula for solving other problems. Suppose here a square plus 2ab plus b square, a square plus 2ab plus b square. We have to check whether it is an identity or not. Whether it is an identity or not. Actually, a square plus 2ab plus b square means this can be written as a plus b whole square. A plus b whole square formula is a square plus 2ab plus b square. So we are having LHS part, RHS part. So this is an example of equation. This equation, it's a normal equation. We want to check it whether it is identity or not. Identity means we have to substitute different values in the place of a and b. If LHS equal to RHS for all the values, which we have taken, then it is considered as an identity. Let's take a equal to 2 and b equal to 3. Now a square, 2 square, 2 into a into b, 2 into 2 into 3, b square, 3 square. LHS part. RHS part, a plus b. Sorry, so let's do LHS part first. 2 square, 4, 2 into 2 into 3, 12, 3 square, 9, and the sum is 25. LHS we have got 25. What is the RHS here? A plus b whole square. RHS a plus b whole square. In the place of a, 2 we are keeping. In the place of b, 3 we are keeping. 2 plus 3 whole square, 5 square, which is equal to 25. So LHS equal to RHS. Hence it is proved. Like that, we can take negative values also. A equal to minus 1, B equal to minus 2. Like that, we can cross check with all the values. But still, it will become true. If it becomes true for all the values, then it is considered as an identity. 1 minute, children. See here, children. Same equation. Now they have taken a equal to minus 1 and b equal to 5. With these values, they are checking the LHS. A equal to minus 1. So A square minus 1 whole square, 2 into A into B, 2 into minus 1 into 5, B square, 5 square. So minus 1 whole square is 1, 2 into minus 1 into 5, minus 10, 5 square is 25, 1 plus 25, 26, minus 10, 16. LHS we have got 16. RHS, A plus B whole square, minus 1 plus 5 whole square, 5 minus 1 equals to 4, 4 square, which is equal to 16. So LHS we have got equal to RHS. So we have with the two different values here and here, we have proved it is true. Similarly, we can prove that it is also true for all the values of A and B. So therefore, it is an identity. Therefore, it is an identity. Or this one, suppose if you have x plus A into x plus B, if you multiply here x into x, x square, x into b, xb, a into x, xa, a into b, ab, or x square plus, in these two terms, if you take x as common, you will get a plus b plus ab. Means the product of these two equal to these two. If you write in the form of an equation, so this is also will be an identity. This also will be an identity. Like this, we can form identities. So here, children. So now the other concept is factorization using the algebraic identities. So in factorization, we have learned so many types, taking out the common term that we have learned and grouping the like terms, then taking out the common term that we have learned. And so about factor theorem we have learned, and about remainder theorem we have learned, and x plus 1 is a factor if odd coefficients equal to even coefficients, or x minus 1 is a factor if all the coefficients sum equal to 0. Like that, we learned so many things in our previous videos. Now, factorization using the algebraic identities. That is also mainly perfect square polynomials. Means the polynomials which can be written as perfect squares. Now, a square plus 2ab plus b square, it's a polynomial as it is having many terms. This can be written as a plus b whole square, which is a perfect square. And a square minus 2ab plus b square, which is a perfect square, a minus b whole square. Whole square. Here, children. Here, children. Which are perfect squares? How to identify whether it is a perfect square or not? Here, if the first and third terms are perfect squares, in the given expression, in the LHS, a square plus 2ab plus b square, if the first term is a perfect square, and if the third term is a perfect square, and the middle term, which is second term, which is 2 times of product of square roots of first and third terms. Square root of first term, root of a square into root of b square. Root of a square equal to a, root of b square equal to b. If they are in this form, then they are called as perfect squares. Suppose if anybody asks you, a square plus 2ab plus b square is a perfect square or not? Now already we know the formula. Now we can tell they are perfect squares. But if you don't know the formula, how to identify whether it is a perfect square or not? If the first term is already a perfect square, if the third term is already a perfect square, and the middle term, if it is, or if it can be written as 2 into product of root of first term into root of third term. 2 into root of a square, root of b square, square root cancel, square root cancel, 2ab. If you are able to write in this form, so then it is a perfect square. So the method is children, suppose this is a polynomial, and in polynomial, as it is having 1, 2, 3 terms, as it is having 3 terms, we can also call it as trinomial. We can also call it as trinomial. Okay. Now, how to determine whether the trinomial is perfect square trinomial or not means what? How to identify? Now, a square plus 2ab plus b square is a trinomial. Is it a perfect square or not means 2 terms must be perfect squares. In the given trinomial, in the given 3 terms, 2 terms, usually the first term and last term should be or must be perfect squares and must be preceded by plus sign, must be having plus symbol before it. A square before there is nothing means we can take it as plus a square. Both of them should be preceded by plus symbol. That is one thing. And the remaining term, usually the middle term, must twice the product of square roots of perfect square terms. Twice the product of square roots of first 2 terms. If these conditions are satisfied, we can tell the trinomial is a perfect square. Next one. If the trinomial is a perfect square, then how to factorize means? First step, find the square roots of 2 perfect square terms. A square plus 2ab plus b square are there. These 2 are perfect square terms. What is their square root? Root of a square is a, root of b square is b. Like this, we have to find the square roots of perfect squares. Then we have to connect them with the sign of remaining term. In a square plus 2ab plus b square, if these 2 are perfect square, what is the remaining term? 2ab. We have to connect the square roots of first and third terms with the sign of remaining term. Remaining term is having plus sign. So these 2 should be connected by plus symbol. Now we have got a binomial. Actually, a square plus 2ab plus b square is a trinomial. In its factor, we got a binomial. This binomial should be used 2 times. This binomial to be used 2 times. So like this we can factorize a plus b into a plus b whole square. So this single term twice is used as a factor. So like that we can write the factor children. Suppose let's see the example children. You have 4x square plus 20xy, 25y square. We have to check first and third terms whether they are perfect squares or not. 4x square means 4 can be written as 2 square. X square means 2x whole square. We can write it as 2x whole square. First term is a perfect square. 25y square, third term, can also be written as 5y whole square. 5y whole square. Middle term 20xy is there. It should be written in the form of 2 into square root of first term 2x whole square, square root of 5y whole square. Square root cancel 2x, square root cancel 5y, 2 into 2x into 5y. 2 to the 4, 4 5 times 20, x into y, xy. It's perfect. We were able to write in the form of twice the product of square roots of first and third terms. So now what is the factor? Square root of first term 2x, square root of last term 5y should be connected by middle term symbol, which is plus. So this is the factor, and twice we have to take it twice. 2x plus 5y, 2x plus 5y, which is equal to 2x plus 5y whole square. Or another example, children, m square plus 3m plus 9 by 4. M square is a perfect square. 9 by 4. 9 can be written as 3 square. 4 can be written as 2 square. We can write it as 3 by 2 whole square. So m square 3 by 2 whole square. The middle term 3m, 2 into square root of first term into square root of third term. Root cancel, 2 into root square cancel, 2 into m, root square cancel, 3 by 2. 2 gets cancelled, m into 3, 3m. We can write like this, which is equal to 3m. So it is following the rules. It is following the rules. So what is the factor? Square root of first term, which is m, square root of third term, which is 3 by 2, connected by middle term symbol, plus. But this is one factor to be taken twice. Second factor also the same. If we multiply both, we can take it as m plus 3 by 2 whole square. So like this, children, by using a square plus 2ab plus b square equal to a plus b whole square identity, we can factorize a trinomial and we will get binomial twice. Same binomial 2 times we will get as a factor. Means suppose if this is the trinomial, we can find one more thing, children. Square root of this trinomial 4x square plus 20xy plus 5y square. Square root of this polynomial how much? If anybody asks means you can directly write it 2x plus 5y whole square. This trinomial can be written as binomial whole square. Square root square gets cancelled. What is the square root of trinomial? It will be equal to the binomial. It will be equal to the binomial. Like the square root of this trinomial equal to x plus 3, or square root of this trinomial equal to this 2x plus 5y. So we can factorize, or we can find the square root of the trinomial by using this identities. Here, children, you have some more examples here. 16a square minus 40ab plus 25b square. 16a square can be written as 4a whole square. 25b square can be written as 5b whole square. This middle term 2 into square root of first term into square root of second term. Like this we can write. After writing this, we have to cross check. 2 into 4, 8. 8 into 5, 40. A into B, AB. It's correct. Now, what is the factor? This square root of this perfect square, 4a. Square root of 5b square, 5b. Connected by the remaining term symbol, which is minus here. Not plus, children. Here it is minus. So, they are connected by minus. So, here they have taken this as first term, this as second term, this as third term. Like that also they can take. But we have to take what? Square root of first perfect square, square root of second perfect square connected by the other term symbol. That will be the factor. Or this one, x square plus 5x plus 25 by 4. X square plus 5x plus 25 by 4. X square they have taken. Next 25 by 4 they have taken. 25 means 5 square, 4 means 2 square, 5 by 2 whole square. And third term 2 into square root of first term, square root of this second term, 2 gets cancelled, which is equal to 5x. Now what is the factor? Square root of first perfect square, square root of second perfect square, connected by other term symbol, which is plus. Next children, find the product using appropriate identity. So a plus b into a plus b, children, we know that it is equal to a plus b whole square. It is equal to a square plus 2ab plus b square. So this is the identity which is proved that it is already right. So we have the identity a plus b whole square equal to a square plus 2ab plus b square. Now they have given x plus 4 into x plus 4, which is equal to x plus 4 whole square. As per this identity, it can be written as x square plus 2 into x into 4 plus 4 square, or x square 2 into x into 4, how much? 8x plus 16. Like this also we can write. That's all for today, children. Remaining topics we can learn in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.